More than 40 million miles of asphalt roads stretch across the planet, quietly carrying every shipment, every journey, and nearly the entire modern economy. Few people realize that behind every asphalt road lies a remarkable journey. From crude oil extraction and stone processing to asphalt production and final construction at the job site. Every stage must work together with extraordinary precision to create a pavement strong enough to endure years of constant use. So how can these raw materials be transformed into a road durable enough to carry millions of vehicles for decades? Let's explore the complete asphalt production process. Every year, the world produces roughly 1.6 billion tons of asphalt, enough to build and maintain hundreds of thousands of miles of roadway. In the United States alone, more than 94% of all paved roads are surfaced with asphalt, supporting an industry worth tens of billions of dollars each year. From neighborhood streets and interstate highways to freight routes and airport runways, this material forms the foundation of modern transportation and keeps people, goods, and entire economies moving. Yet asphalt is not only produced on a massive scale, it is also one of the most recycled materials on Earth. Each year, hundreds of millions of tons of worn pavement are milled from old roads and sent back to asphalt plants, where they are processed and reused in new mixtures. This practice saves millions of tons of stone, sand, and bitumen, while reducing construction waste and carbon emissions. Because it can be recycled again and again without losing its essential value, asphalt has become one of the most practical, efficient, and sustainable building materials in use today. Few people would imagine that the journey behind an asphalt road begins in some of the harshest environments on Earth. Some oil fields lie in the middle of vast deserts, while others are buried deep beneath the ocean floor, where offshore drilling platforms weighing as much as 40,000 tons must operate continuously through powerful waves and severe weather to reach the valuable resources hidden below the seabed. To accomplish this, drilling rigs may have to bore more than 13,000 feet, or about 4 kilometers, beneath the surface, cutting through multiple layers of solid rock before reaching an oil-bearing formation. Throughout the operation, drilling fluid is continuously pumped down the well to cool the drill bit, stabilize the wellbore, and carry broken rock fragments back to the surface. Once the drill reaches the reservoir, natural underground pressure initially forces the crude oil upward. But as that pressure gradually declines, the familiar pump jacks take over, moving in a steady rhythm as they draw the remaining oil from deep underground. The crude oil is then transferred into enormous storage tanks before continuing its journey through pipelines, oil tankers, and tanker trucks to the refinery. When crude oil arrives at the refinery, it is pumped through large heating furnaces and raised to approximately 700 degrees Fahrenheit before entering a distillation tower that can stand several dozen meters tall. As the oil moves through the tower and the temperature changes, its different components begin to separate according to their individual boiling points. Liquefied petroleum gas, gasoline, jet fuel, and diesel are gradually collected at different levels inside the tower. By the time nearly all of these valuable products have been removed, only a thick, black liquid with extremely high viscosity remains at the bottom. This substance is bitumen, once considered one of the least valuable residues left behind during crude oil refining. Today, however, its role has completely changed. Bitumen has become the essential binding material that holds stone, sand, and mineral particles together, making it possible to build more than 40 million miles of asphalt roads across the world. If bitumen serves only as the binding agent, then aggregate stone is what provides the true strength of a road. This journey takes place in enormous open-pit quarries. To reach the untouched bedrock that has remained buried for hundreds of millions of years, everything begins with carefully planned overburden removal. Heavy excavators and fleets of articulated scrapers move in, stripping away the surface soil, vegetation, and weathered rock. The quarrying process relies on industrial blasting. It all begins as enormous crawler-mounted drilling rigs move into position along the edge of the rock face. These machines drill rows of holes into the hard rock surface at a precise 15-degree angle. Each drill bit penetrates as deep as 20 meters, cutting through the rock at a rate of up to 5 feet per minute. The steel drill continuously hammers and rotates at extremely high speed to break through rock formations hundreds of millions of years old. The purpose of this stage is to weaken the rock into areas precisely calculated to receive the force of the upcoming blast. Once the drilling is complete, workers begin loading large quantities of industrial ANFO explosive into the holes. Each borehole is connected to a modern electronic detonation system. From a safe distance, the supervisor presses a button on the control box to initiate a precisely timed sequence of blasts rather than detonating every charge at once. This creates a series of controlled shockwaves that prevent the surrounding area from being shaken too violently. A standard blast can produce between 15,000 and 25,000 tons of raw rock in an instant. In some cases, the entire process can release as much as 500,000 tons of solid rock. Even before the rock dust has fully settled, enormous tracked excavators immediately move in, scooping up bucket after bucket of stone weighing tens of tons and dumping it into ultra-heavy-duty mining trucks. After only a few bucket loads, each truck is filled with rock and quickly heads toward the crushing area. Leaving the quarry, massive 100-ton haul trucks roar into the crushing and classification area. One by one, the trucks raise their beds, dumping more than 40 tons of rock into the feed hopper of the primary jaw crusher, and sending thunderous impacts echoing throughout the entire production line. Towering as high as a 4-story building, this brutal machine uses the continuous reciprocating motion of 2 reinforced steel jaws to crush 3-foot boulders down to pieces measuring just 6 to 10 inches. With a crushing capacity of 3,000 tons per hour, it can easily produce enough material to fill 30 freight cars in only 60 minutes. Once the primary crushing is complete, conveyor belts immediately carry the entire stream of aggregate to a cone crusher, where it is compressed once again into smaller sizes. The material then flows continuously from the crusher into a multi-deck vibrating screen system, where thousands of vibrations per minute rapidly separate it into different size categories. Oversized rocks are returned to the crusher for further processing, while particles that meet the required specifications fall onto separate conveyors and are transported to individual stockpiles. Remarkably, almost none of the stone is wasted. Large rocks, smaller particles, and even stone dust are all used in different proportions to create the strong structural framework of the pavement. Once the aggregate stockpiles are filled, wheel loaders transfer the materials into trucks for delivery to the asphalt mixing plant, ready for the next stage. Once the aggregates arrive at the asphalt plant, engineers begin determining the mix design for each batch of asphalt. In the laboratory, technicians collect samples, test them, and carefully weigh each type of stone, sand, mineral filler, and bitumen to calculate the optimal blending ratio. Every type of pavement, from city streets and highways to airport runways, requires a different formula. A change of just 0.5% in the bitumen content can significantly affect the pavement's durability and resistance to rutting. Once the design is finalized, all parameters are entered into the control system, preparing the plant for fully automated production. Once the mix design has been finalized, the entire production line begins feeding materials automatically according to the preset proportions. Wheel loaders deposit each type of stone, sand, and mineral filler into separate feed bins. After each type of aggregate is loaded into the feed bins, it is precisely metered and discharged onto the conveyor system below. The materials then combine into a single continuous stream and are carried directly into the rotating dryer drum. Conveyors beneath each bin continuously draw out the material at flow rates calculated by the control system. Inside the drum, a burner generates hot air, reaching approximately 300 to 350 grace Fahrenheit, drying and heating the aggregate as the drum rotates continuously to keep the material evenly mixed. This stage is especially important because even a small amount of moisture remaining on the aggregate can prevent the bitumen from coating the stone evenly, weakening the bond throughout the entire mixture. Smoke and dust produced during the process are also drawn through a filtration system, where mineral fines are recovered and emissions released into the environment are reduced. Once the aggregate reaches the correct temperature, the entire production line enters its most important stage, creating the asphalt mixture. The heated aggregate is lifted to the top of the mixing tower by a bucket elevator and passed through a vibrating screen for final classification. Each size group then falls into a separate storage bin and is weighed precisely according to the programmed mix design. Meanwhile, the bitumen is heated to approximately 300 to 340 degrees Fahrenheit, 150 to 170 degrees Celsius, keeping it in a liquid state before it is pumped into the mixer. Mineral filler and additives are also introduced in the required proportions, allowing the mixture to achieve the specific properties demanded by each type of pavement. Once every component is ready, the discharge gates open simultaneously, releasing all the materials into the mixer. Powerful mixing blades continuously turn, toss, and coat every aggregate particle with bitumen for approximately 30 to 45 seconds, until the entire mixture develops a uniform black appearance. Before being transferred to the silo, the mixture is quickly screened to remove clumps, oversized particles, or any material that fails to meet the required standards. At this point, each stone particle still performs its individual load-bearing role, but its surface is now wrapped in a thin layer of bitumen, creating a hot, cohesive asphalt mixture ready to be laid, leveled, and compacted at the construction site. Even a slight error in the bitumen ratio or an uneven coating can cause the finished pavement to develop raveling, cracks, or rutting much sooner than expected. Once the process is complete, the hot asphalt mixture is discharged into a storage silo, ready for transportation to the job site. Before leaving the plant, every batch of asphalt must undergo a final inspection to ensure it meets the required quality standards. As soon as the mixing process is complete, technicians collect a sample of the hot asphalt for testing. First, they measure its temperature to make sure the mixture remains between 290 and 330 degrees Fahrenheit, allowing it to be transported and placed properly. Next, they verify that the bitumen content matches the specified formula and that every stone particle has been coated evenly. A deviation of only about 0.5% in the bitumen content can cause the pavement to deteriorate prematurely or develop rutting. Many plants also collect samples after every 200 to 500 tons of asphalt to maintain consistent quality throughout the entire production process. Only after passing all of these inspections is the asphalt mixture allowed to leave the plant. Once the asphalt meets the required specifications, it is not loaded directly onto trucks for immediate delivery. Instead, it is first discharged into insulated storage silos. These silos keep the mixture at approximately 300 degrees Fahrenheit, 150 degrees Celsius, allowing the asphalt to remain workable while it waits for transportation. When a specialized truck moves into the loading position, the discharge gate beneath the silo opens, releasing dozens of tons of hot asphalt into the truck bed within only a few minutes. Before loading, the bed is coated with a biodegradable release agent that prevents the asphalt from sticking to the sides while remaining environmentally safe. Once the truck is fully loaded, it is weighed again to confirm the correct payload, then covered with an insulated tarp before leaving the plant. From this point on, the process becomes a race against time. If the asphalt cools too much during transportation, it begins to lose its workability, becomes difficult to spread evenly, and may reduce the overall quality of the finished pavement. After leaving the mixing plant, the hot asphalt mixture is quickly transported to the construction site in specialized dump trucks with covered beds to minimize heat loss. Before paving begins, workers remove all dirt and loose material, then level the underlying base. Even a single uneven area or pool of standing water can weaken the bond of the new pavement and cause premature failure. Each truck backs up closely to the paver and slowly raises its bed, releasing the hot mixture into the receiving hopper. Inside the machine, conveyors and augers continuously move the material toward the rear and distribute it evenly across the full paving width. The operator must maintain a steady speed because any sudden stop can leave ripples or weak joints across the surface. Immediately behind the paver, rollers move in while the asphalt is still hot and workable. Steel drum rollers make the first passes, pressing the aggregate particles tightly together, removing air voids and shaping the surface. Pneumatic tire rollers then apply even pressure across the material, helping the stone and bitumen lock together into a dense, solid mass. Final rolling passes smooth out tire marks, joints, and any remaining uneven areas. This stage is a direct race against temperature. As asphalt cools, it becomes increasingly stiff, making it much harder to achieve the required density. Too little rolling leaves excessive air voids, allowing water to penetrate and cracks to form quickly. On the other hand, excessive or overly aggressive rolling, while the mixture is still soft, can push materials sideways and deform the surface. Throughout construction, engineers continuously check the asphalt layer's thickness, slope, smoothness, temperature, and degree of compaction. Road edges and joints between paving passes are also treated carefully to prevent weak points from forming. Only after the entire surface meets the required specifications is the pavement allowed to cool and stabilize. From a hot mixture of stone, sand, and bitumen, the paving operation creates a smooth, dense roadway capable of carrying millions of vehicles for many years. And with that, the journey of producing asphalt, the lifeblood connecting the world, comes to an end. Behind every stretch of road are vast, monumental production facilities operating around the clock. If you still have any questions, leave a comment, and Factron Process will help you find the answers.